Hi. If you're an astrophotographer, then you probably know the problem of planning your pictures. My name is Pál Váradi Nagy, and let me show you my solution. This URL here points to a website I made. Let's go there. This website is made of the Aladdin Light API and front end from the University of Strasbourg. It's a public API, you can use it and build on it. And I also use their database and backend, which is built into the Aladdin Light, but I made my own database based on this guy's work. So Astronexus made a very valuable collection of data, but I also needed some extra, we'll see. So I'm not good at naming my software, so this is the Aladdin to Photo Planner. This panel here is my contribution. This is the Digitized Sky Survey, the pictures, and you can see the Aladdin logo here and some other Aladdin controls here. This is the main panel with one single input. It's almost like your favorite search engine. It has one input and you can type here some basic searches or some complex searches. Let's see a very basic one. M31. We all know it. The Andromeda galaxy. Okay. What do we see here? The main panel displays some info. The search result. This one comes from my database, this one comes from Aladdin if you don't have your internet connection, but if you have my source code, I will publish it sometimes in the near future. This one works in an offline mode too, and for this there is the Strasbourg University that needs to be online, reachable. Okay, we see some buttons here, the imaginary lines we'll see, the instrument we are using, the focal length and the sensor. We can rotate the sensor. And the geolocation, please don't bother, this is not my real geolocation, this is an obfuscated one. And by the way, if you are worried about your data, then check out this here. It's almost accurate, but it's not your real data here. Neither is my real location, so please don't bother looking me up on Google Maps. Okay, so we have the moon info and some other buttons and the picture. About my privacy, yeah, you know, the European law, the GDPR and the other stuff. I assume that if you are using my website, then you trust me. If you don't, then please don't use my website. I need your real geolocation to make the astronomical calculations, so worry about your IP address more than your geolocation, which can be obfuscated or entirely fictive. Okay, so we made a simple search. M31 for tonight, Wednesday. No, this is the date and the local time. We have the name of the object. We have some basic info about its luminosity, its position, its J2000, its real-time altitude and azimuth, its east-southeast. We have some info about its size, about the maximum altitude it reaches in darkness, for how long this object stays in darkness. Darkness meaning the sun is below minus 18 degrees altitude and the moon is below the horizon. And when it reaches its lowest altitude during darkness, and when does it cross the meridian. You can see it's well, it's the perfect season to picture the Andromeda galaxy from the northern hemisphere. And these are some checkboxes I checked, suggesting that this object is a suitable target for these focal lengths, assuming an APS-C sensor. I can obviously change the sensor, and you can see as the field of view changes that the shape of this rectangle is different, and the moon just got bigger. This is for reference, and these lines are also for reference. If I go to a ridiculously large focal length, no amateur pictures of this, you can see that the reference moon got very big, and these lines indicate 0.1 degrees. Let's go back to 750. If you don't know the number, the catalog index of an object, then you can look for its name, like the Skull Nebula. Who knows the Skull Nebula's NGC or IC number? Hello, Sky Nebula. Skull, I mean. So this is how the Skull Nebula looked like in my instrument. For tonight I had 3 hours to picture it, while the object stays at a minimum of 20 degrees altitude. You can see it's the perfect time to picture this nebula. It's around midnight. These are local times. But what if I just want to look at some object, I don't know, M102, that's a problematic mess here. M102, let's go, yay! There's the object. But what if, and here comes the power of my program, what if I want a complex search? Then I can build a complex search here with the composer. You can check out, read the options here. But what if I want to go further and I want the software to compose for me a list of objects that are available for this Friday for my instrument? Let's see which targets it proposes. Obviously. Oh, let's go back to Canon. Like this. Okay. Let's repeat the search. And set this rectangle to 0. Okay, so North America Nebula, very obvious. The double cluster, obviously. And my workflow, the owl cluster. I don't like the name ET. My workflow is printing this. Anyone who's ever seen short exposure through a telescope knows that these are the stars that are going to be visible and nothing else on a short exposure, so you really need some indicators about where your telescope is pointing exactly and how to rotate the field of view. Now, these are the basic info, the title, the coordinates, the location. There is no geolocation associated with these coordinates. The viewing date time, max altitude, we can still wait a month. Yes, this is going to be on paper. The paper doesn't deplete its battery. Its screen won't get scratched. Paper just works, bitches. I like paper. Let's go back. So we can use this software to propose targets, to preview a photo, how it would look like. For example, the Cocoon Nebula. The Cocoon Nebula. Okay, let's see. And let me show you my picture of the Cocoon Nebula. Here. This is the picture I made based on about this view. Obviously cropped a bit, but here it is. And so on. And let me show you just one more interesting thing about this. Let's see some planetary nebulae whose size is at least 0.1 degrees. This means 6 arc minutes. And minimum luminosity of 10. And minimum photogenic time of 2 hours for Friday. And let's see, we have the Helix Nebula. It's a well-known target. We have then the Sharpless 174. Well, if you like a challenge. We have the Dumbbell Nebula. It's again an obvious target. And these are the deep sky objects fitting our criteria, which were planetary nebulae of at least 6 arc minutes, of minimum 10 magnitudes, and a minimum of 2 hours time to photograph the object. This proposal box here works really nice. You don't have to memorize these switches, you don't need to be a programmer to use this. You can read it here, or you can just use the help. Let's check out the help with some, for example, nice Fortunite, nice spiral galaxies. Let's see, do we have nice spiral galaxies? Let's plot them, and here we are. Here, these are some nice spiral galaxies. I told you about these buttons. I can switch off the imaginary lines, or I can select which lines to display. You can see the green grid here for the altitude azimuth. Okay. Let's see some popular target Leo triplet. Yeah, let's go there. How would I picture this? Well, like, let's say like this. Let's see it as a picture, and I can print this. So I can use my mount's goto function to go to these coordinates, these exact coordinates, and just start with imaging. Okay, this video is going to get very long. I'll stop here. Have fun using my software. It's free, it will always be free. I try to maintain it, and sometime in the near future, I don't know when, I will publish the source code so you can go and have fun with it, with all its bugs and hello, this is the moon, and all its ugliness in the source code. I didn't really develop the source code to be beautiful or to satisfy some good coding practices. It just works, and I think this is a feature. It works. So thank you for your attention. Use this website, the csillagtúra.ro/Aladdin. Goodbye.